Good day, everyone. Today we are going to start the part 2 of chapter 1, which is solutions. We have already completed part 1, that is the concentration terms, and today we are going to complete the solubility part, which is in part 2. So, first, let's start the topic. So, what is solubility? It is the maximum amount that can be mixed up in a specified amount of solvent under specified conditions. The units of solubility are mole per decimeter cube and gram per meter cube and per 100 grams of solvent. And it will depend on the nature of solute, the nature of solvent, and the amount of temperature and pressure. Now we will study the solubility of a solid in a liquid. So usually when a solvent is mixed in a solute, if the inner intermolecular interactions are similar in the two, and the solubility of the solid in a liquid at any given amount of the temperature is defined as the maximum amount of solid in grams which will be mixed up in 100 grams of the liquid, that is the solvent, to form the concentrated solution at that particular given heat. Now we will see what is the process of solubility of a solid in a liquid. So when a solid solute is added continuously in a solvent, the solute will keep on mixing up and the concentration of the solution will increase. So this is called dissolution. While some solute particles in the solution will collide with the solid solute particles and get separated out of the solution, which is called crystallization. So a stage is reached when the number of solute particles going into the solution is equal to the solute particles separating out of the solution. That is, these two processes will occur at the same rate, and hence a state of dynamic equilibrium is reached. At that particular stage, the concentration of the solute in the solution will remain constant under a given amount of pressure and heat which is provided. So, similar processes followed when the gases are mixed up in liquid solvents. So, the process of mixing up of this solute in the solution will contain or will continue until the solution attains a certain maximum concentration. So, such a solution in which no more solute can be added at a given pressure and heat is known as saturated solution. Therefore, saturated solution will contain the maximum amount of solute which in a given amount of solvent. So, the concentration of the solute in such a solution is called its solubility. And an unsaturated solution is the one in which more solute can be mixed without changing the heat which is provided under a given provided pressure. Now let us talk about the factors affecting the solubility of a solid in a liquid. So the first factor is the nature of the solute, which is the solid part, and the solvent, which is the liquid part. So we know that like will mix with the like, so it means that polar or ionic compounds like NaCl will mix up only with the polar solvents like water, and they are almost insoluble in non-polar solvents like benzene. Similarly, the non-polar compounds like naphthalene are soluble in non-polar solvents like benzene or ether and are less soluble in polar solvents such as water. Moving to the next factor, that is effect of the amount of temperature. The solubility of a solid in a liquid is significantly affected by this factor. So let us consider a saturated solution which represents the equilibrium between a solute and the mixed up and the non-mixed up solute. So the equation will be like this. And here the change in enthalpy can be negative or positive. So during being dynamic equilibrium, they must follow the Le-Chatelier's principle. So according to which, if the change in enthalpy is negative, then the solubility will reduce. And if the change in enthalpy is positive, then the solubility will increase. And if the enthalpy is negative, then it is an exothermic reaction, and if the enthalpy is positive, it is an endothermic reaction. Moving to the next factor, that is the effect of. So there is no much effect because the solids and liquids are almost incompressible, practically remain unaffected by the pressure change. Moving to the next category, that is the solubility of gas in a liquid. Until now, we have studied about the solubility of a solid in liquid. Now, we'll study about the solubility of gas in a liquid. So, almost all the gases are soluble in water, but at different rates. That is, with the provided same pressure and the amount of heat. Now, the factors affecting the solubility of gas in a liquid. The first factor is the nature of solute and the solvent particles. So the solubility of different gases in the same solvent will vary. So the gases which can be easily liquefied are more soluble in common solvents. That is, gases like hydrogen, oxygen, nitrogen and helium will mix up with water in small extent, whereas gases like NH3, HCl, SO2 are highly soluble in water. Next is the effect of heat or the effect of the amount of the temperature. If it increases, then the solubility will reduce and the reaction is exothermic. That means the enthalpy, the change in enthalpy is negative. It will happen because when a gaseous solution is heated, the molecular motion of the gaseous particles will increase. As a result, some molecules escape out of the solution. And therefore, according to the Le-Chatelier's principle, in the above equilibrium, the increase of temperature would push the equilibrium towards backward direction, that is towards endothermic side, and this results in the reduce in the solubility. And next is the effect of pressure. So if pressure is increased, solubility will also increase. So here we can observe that if we place certain amount of weight on top, then the number of molecules are these, and if we increase the weight, then the number of molecules will keep on increasing, and therefore if the pressure is increased, then the solubility will also increase. So in order to explain the effect of pressure on the solubility of gas, Henry has come up with a reaction, and that has come to the formation of Henry's law. So William Henry was the first to give a quantitative relationship between pressure and solubility of gas in a solvent. That is why it is called Henry's law. So it states that at a constant given amount of the temperature, the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of the solution or liquid. So, in most common forms of Henry's law states that the partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas in the solution. That is, the vapor pressure is directly proportional to the mole fraction, and when we remove the proportionality, we'll get a proportionality constant which is Kh. So this proportionality constant is called Henry's law constant, and its units are kilobar or torr. A question is provided for you to solve, and you'll know the answer in a while. Next, the applications of Henry's law. So, it is useful in the production of carbonated beverages. So, to increase the solubility of CO2 in soft drinks and soda water, the bottle is sealed under high pressure because pressure will increase the solubility. And it is used for people living at high altitudes or climbers. So, at high altitudes, the partial pressure of oxygen is less than that at the ground level. So, this leads to the low concentration of oxygen in the blood, and for the people living at higher altitudes or climbers. So, consequently, they feel weak both physically and mentally, and they are symptoms of medical conditions known as anoxia. And it has an application in deep sea diving. So, scuba divers breathe air at high pressure underwater. So, increased pressure increases the solubility of atmospheric gases in the blood. So, when these scuba divers come towards surface, the pressure gradually decreases, resulting in the release of the gases from the blood. So, this leads to the formation of the bubbles of nitrogen in the blood, which block the capillaries and give rise to ailment called bends or decompression sickness. So, to avoid these, as well as the toxic effects of high concentrations of nitrogen in the blood, the scuba divers have the carry with them the cylinders which are filled with dilute helium, that is which 11.7% of helium and 56.2% of nitrogen and 32.1% of oxygen. Now, going to the limitations of Henry's law. It is only applicable when the pressure of the gas is not too low. It is because at high pressure the proportionality constant will show considerable variations, and hence the law becomes less accurate, and the amount of heat provided should not be too low, and the gas should not undergo any chemical change, and the gas should not undergo any association in the solution. We have completed the basic explanation. Now the answer to the question which is provided. So the question is that H2S, a toxic gas with rotten egg-like smell, is used for qualitative analysis. If the solubility of H2S in water at standard temperature and pressure is 0.195 m, then calculate Henry's law constant. So what is provided to us? The solubility of H2S, which is 0.195. That is 0.195 moles in 1 kg of solvent, which is water. So the number of moles of H2O in 1 kg of solvent is 1000 grams by 18 grams per mole, which is the molar mass, which is 55.5 moles. Now the mole fraction of H2S. We already know the moles of H2S and we know the moles of water. So the moles of H2S by total moles of the solution, which is equal to the mole fraction, that is 0.0035. So we have to find the Henry's law constant, which is the pressure of H2S by the mole fraction of H2S. So the pressure of H2S is 0.987, that is at standard temperature and pressure, and the mole fraction is 0.0035, which is equal to 282 bars. So we have completed the solubility part. Now we are going to give a quick NCERT reading. Now we have come to the solubility part. Solubility of a substance is the maximum amount that can be mixed up in a specified amount of solvent at a specified temperature. It depends upon the nature of the solute and solvent as well as the heat and pressure. Next, every solid will not mix up in a given liquid, while sodium chloride and sugar will readily dissolve in water. Naphthalon will not happen. On the other hand, naphthalon will readily dissolve. So we can say that like will mix up with the like. So already completed all this part. I've explained you what is saturated solution, unsaturated solution, Lake-Letelier's principle, and solubility of a gas in a liquid, and the effects which we see, the factors which are affecting, and then the effect of pressure. So if we apply more pressure, then more amount of gas will be mixed up in the liquid, and Henry's law is done. And this is the graph which we can see for Henry's law. So we'll speak about the significance of Henry's law and Henry's law constant. So here the slope which is provided is the KH, that is the Henry's law constant. So what is the significance of Henry's law? So Henry's law is applied to each gas independent of the presence of the other gas. So if two or more gases are present also, you can apply Henry's law on one particular gas. And various gases will have different values of K in the same solvent and at the same provided heat. So from this we can understand that KH is a function of the nature of the gas, and KH values of a gas is different in different solvents. Moreover, this value increases with increase in the amount of heat which is provided. We can understand this part by this given table. So if we have high value of KH, then the solubility is low, and this point is very important. That is the reason why aquatic species are more comfortable in cold waters rather than hot waters. So that is that the temperature indicating that, so the increase in the temperature will indicate that the solubility of the gas increases with decrease in the temperature. These are the important points to note in the NCERT. We've also completed with the applications of Henry's law, that is about CO2, scuba divers, and people living at higher altitudes, and the effect of temperature. And we've also dealt with the limitations of Henry's law. And there are some in-text questions provided for you, and I've already completed this question. Solve the in-text questions provided in the NCERT and give a quick reading to the NCERT as well. And tomorrow we are going to complete the vapor pressure of liquid solutions. So we have completed part 2, and very soon we are going to complete the vapor pressure of liquid solutions. Thank you so much for watching. Stay tuned for more parts of the video.